In this video I'm going to do polynomial division. I have another video on polynomial division as well using generic rectangles. However, this one I'm going to do long division. So I'm going to divide this polynomial, x to the fourth plus x to the third minus 8x squared minus x plus 10, divide that by this polynomial x minus 2. So to do that, the first thing I look at is the x to the fourth and this x. And I want to know how many times does x go into x to the fourth? Or what is x to the fourth divided by x? That is going to be x to the third. So my answer for that goes right up here, x to the third. The next step for this process now is I take that, x to the third, and I multiply it by my divisor of x minus 2. When I do that, I end up getting x to the fourth minus 2x to the third. What I'm now doing is I'm taking these two right here, and from that I'm subtracting away these two. So essentially I'm going to subtract that from the two above it. Now instead of subtracting, I would rather use addition, so I distribute my negative here and distribute my negative there, and essentially what that does then is switch the signs to a negative there and a positive. Now I can add, and when I add them, those will make 0, and then I have 3x cubed left. Before I do my next step, I take the next term here and I bring it down, and that is minus 8x squared. I now repeat the process. How many times does x go into 3x to the third? So 3x to the third divided by x, that is going to be 3x squared. So I have a positive 3x squared. I once again take that and multiply it by the divisor. So I get 3x cubed minus 6x squared. Subtracting that from the one above it means I'm again distributing the negative, and I can add. So I switch my signs, and now I add them. Once again, those make 0 because I designed it that way. When I add the next two, I get a negative 2x squared, and my next term comes down minus x. I go through and continue the same process. So how many times does x go into negative 2x squared? That's going to be a negative 2x times, multiplying times those two, and I end up getting negative 2x squared plus 4x. Switching my signs makes that a positive and a negative there. Adding them together, I get 0, and I get a negative 5x. Bring the 10 down, and again repeat the process. X goes into negative 5x, negative 5 times. I multiply the negative 5 times my divisor, and I end up getting negative 5x plus 10. Switch my signs and add them, and I get 0. Which means I do not have a remainder for this problem. And the solution, the answer when I divide them, is this polynomial, x to the third plus 3x squared minus 2x minus 5. If there's a remainder, the only difference here is that when you use this number and bring it down, it does not match up, and whatever number would be left would be a remainder. For instance, if I would switch this problem And we would say this number was not a 10, but rather an 8. So when I bring that down and have an 8, now when I add those two together, I actually get a -2. So my remainder would be a -2, which would switch my answer to plus a -2 over x minus 2. And the solution would now be all of that with the remainder.